Okay, what are the targets of our course? We want to give an overview of the history of microprocessors, and we want to understand the initial own programming language of computers. And there we in particular focus on 8-bit microcomputers, microprocessors. And inside this initial own programming language, it's important to focus on aspects of assembly. Assembly is a programming language that is very near to this initial own programming language of the computer. To interrupts, it's a very essential concept of microprocessors. And then also registers. Registers are special memory cells that fulfill a certain function. And also we want to give an overview of microcomputer architectures. Okay, this is a block diagram of the 8051 microprocessor. So this 8051 microprocessor is an 8-bit microprocessor and has a long history from the 70s and 80s on. It was developed by Intel. And what you see here is a block diagram of the internal registers and processing units of this chip, of this CPU chip. And we come to these parts later. Just I want to show you this as an appetizer right now. Yeah, programming languages. Maybe you remember from the first year we learned programming with C and Python. And in the context of our present course, this would be this area here. And this is a programming language that is understandable to humans. And on the other side, we have maybe programming languages that are more understandable to computers. And there is the machine code already mentioned. And so that is the language the computer can understand. And we can see also there's the role of the C compiler, basically translating a human understandable program into a computer understandable program. So that would be back, if we go back to the first year. And now we have somehow this assembly programming language that is in between, actually more on the side of the machine code. So we focus here on a programming language that is designed just to visualize aspects of the machine code. That's the core of assembly, so to speak. And also assembly needs to have a compiler, an assembly compiler, a very primitive, simple compiler then that translates these basic instructions into the numbers that represent the machine code. So the content of this current course is inside this blue framed rectangle that we see here. So you learn here all these aspects. We will learn here machine code, how this machine code acts on our CPU for 8-bit microprocessors. And we will also see how a little bit into the terms of the C compiler, the assembly language we learn very extensively for the 8051. We'll see how the assembly compiler is working. Yeah, and also we are going to focus on some of the peripherals of the 8051. Yeah, here is a picture of our exercise boards that we have developed for this present course. There are also other exercise or other boards on the market, and we see if we can use maybe one of them during the course, because we don't have enough of these boards right now to give everybody one. We are going to form groups of 2 to 3 students who are working with one of these boards, and let's see how the things develop over the time during this semester. Yeah, what can we see on our exercise board? First, maybe you realize this thing here, this metal box is access to USB connector. Um, this is actually not the native connection with which this microprocessor microcontroller is operating. By the way, the microcontroller itself is here. This is the 8051 in 44 pin housing. This microprocessor is initially designed to communicate with UART RS232. So what is necessary is basically a translation chip that translates the USB signals to UART and there to the RS232 standard. And this is this little thing here, what you see. This is so-called RFTI chip. And yeah, this is here used to translate these signals into, so to speak, the native serial bus of our microcontroller. I should also mention here, this microcontroller is not only the CPU, but already many peripherals like computer memory, EEPROM, the programming memory, the RAM, all these things, they are integrated into this chip alone. So in fact, if ever this chip is still used in the industry right now, it can operate as an independent controller, and most of these pins can be actually used as multi-purpose I/O pins for operating some device. Here you see also a connector, and this is the original RS232 serial bus connector. In fact, you see here these switches, 6 different switches, and there you have the possibility to choose between the USB connector and the serial bus connector to connect to the microprocessor. And this setting of these dip switches is the one that is necessary to connect via USB bus. So if something is not working, maybe you check if these dip switches in the beginning are in exactly the setting that you see here. Yeah, only in very special situations the dip switches should be set to another configuration. Yeah, what else do we see? A little bit occluded from the display. Here's a display. Oh, moment. Here's a display. Beyond the display, behind the display, I should say, there are multi-purpose I/O chips, 8255. So these are also, they have also some long history, and they used to be, initially they were developed for a computer system that based on another microprocessor, 885, but they have been used for many other devices. So here also they are used, and here they used for input and output. We see here buttons that can be pushed. So these buttons are controlled by one of these chips, and also we see here an array of 8 LEDs, and is also controlled here. We have also a little speaker here. Later in this course we are going to play music. We can actually program by using interrupts. We can program sounds on this exercise board. Yeah, here is also a RAM IC. So on the board we have 32 kilobyte external RAM. Actually, I should mention here that this is rarely used. We see here 2 buttons. These buttons are related to interrupts. We are going to talk about these also in extension during the course. Here, this is a switch. Basically, here we can switch our microcontroller between the program bootloader mode and the operating mode. So, yeah, also I'm going to explain that later on. Here you can see how you can earn your credits. So we are going to have a midterm exam that is going to be 40%. I hope we are at this point when we have the midterm exam, we are in the state that we can conduct in-person midterm exams at the university. Let's see how far we get with that. And then we have 60% homework and project. The project will be at the end of the semester, and projects are done in groups. So we outline for every group a different little topic that has to be programmed on the exercise board. So this will be a slightly bigger programming task out of some list of suggestions, or also you can come up with your own ideas. And yeah, this will be at the end of the semester, around Christmas time. Okay, then finally I have a flow chart or block diagram of this course, at least the course in the following weeks. We, as I said already, will outline the computer history, go a little bit into universal Turing machines, for Neumann architecture, Harvard architecture. Then we have the more detailed microprocessor part, where we discuss the features of various microprocessors. So the i86 microprocessor, which is basically the microprocessor of our PCs nowadays. Then the microprocessor inside the exercise board, the 8051 microprocessors, and there we will discuss features of particular registers, and these registers, let's start with the most fundamental registers, that are the program pointer and the accumulator, and also the flags. We'll see what that means. And then finally we have the software aspects, programming aspects. So we are going to learn about assembly basics, where I try to get a fundamental understanding of how machine code works with a demo minimal microprocessor. And then I will outline the 8051 machine language, and their different addressing types. And then during the next some weeks, I should say, we will focus on also on jump instructions and arithmetic and logic instructions. And this is of course not the end of the course, but this is just the first some weeks.